Dear student, in the last video we learned about the pin description of 8051. Now we learn about the block diagram of 8051 as well the architectural of 8051. The question asking in this explain the block diagram of 8051, probably they are asking in 6 marks, so you're supposed to know how much you need to write. As well they're going to asking for explain with neat block diagram of architecture of 8051. They're asking for 8 to 10 marks. Then you people has to ready to write with briefly the content. So let me see that. See 8051, these are the blocks we having. One, we have the CPU, require the oscillator, and we have the interrupt controller, and we have the internal RAM, ROM, and timers, serial ports, 4 IO ports, bus control. See, the CPU is communicated with all the modules like your internal memory locations and timers, serial ports, as well as the interrupts. So we'll see that each one by one. Here we learned all the pin configuration and functionality of 8051. So here remember the oscillator gives the frequency of 12 megahertz what from the crystal we design in such a way that it is given that 12 megahertz frequency. Okay, we have the 4 IO ports P0 to P3, each are 8-bit as we learned, and we have the serial ports, that is transmitter and receiving, and timer 0, that is T0, and timer 1, this is timer 0 and timer 1. Okay, and we have the internal memory location. We have this is internal memory, and we have the interrupts. We have two interrupts, INT0, INT1, that is hardware whatever the internal interrupts. Let me see that detailed block diagram. So this is your detailed block diagram. We'll see that one by one functionality of all the blocks. The main CPU consists of the accumulator, and we have the temporary register TMP1 and TMP2, the ALU. These are internally the CPU consists. Along with we have the program status word, and we have the special function registers along with timers, and we have the type B register, particularly designed for some of the operations like multiplication and division. So all we have some space or area for all this register in the RAM area. It has a all memory address for each one. Accumulator, it means that all arithmetic and logic operation performed in the accumulator. It is all 8-bit register, widely used like addition, subtraction, multiplication, division, and other Boolean bit manipulations. A register is also used for a data transfer between the 8051 and any other external memory location. Like we have an external memory location 64 kilobytes. From that we can access a data, or we can store the data into that memory location. Like as we know that we have the one more DPTR, data pointer register. It is pointed to your external memory location. This data I can access through the accumulator. This is the main register. It is also bit addressable register. So we can bit addressable like ACC.0, ACC.1. So likewise we can address these bits, and we can clear or set these bits by using some of the instructions. Next we have the B register. B register is also a 8-bit register. It is used along with the accumulator. It is particularly for multiplication and division. Normally multiplication we are using mul AB, and division also we are using mul AB, divide AB, so that whatever our resultant should be there in both the result register A and B register. And normally this also we can use B register to temporarily store the data. So these are the main registers, and we'll come to the accumulator. Accumulator perform all arithmetic and logical operations. After operating all the arithmetic and logical operation, the PSW gives the status of that ALU content or some of the register content. We'll see that along with that we have the ports P0, P2. It has a driver. All the ports has a driver. And we have the stack pointer, the ports P1, P3, and we have the drivers. And we have the oscillator, internal oscillator is there. We can use the crystal to generate your operational frequency. And this is all controlled by timing and control unit. This is the timing and control unit, and this timing and control unit gives the instruction register. This is what your instruction register IR. So when we learned about PSEN, ALE, EA and reset, when you press the reset, so through this all the content of your processor, it becomes 0. EA bar, external access, so it is 0. It can be accessed the internal, it will be 1. So likewise we learnt in the pin detail. So then we have the main important one like DPTR register. This is the one important one, as well as the program counter. With that, the program counter holds the address of the instruction to fetch and decide which instruction is going to be fetched for the next clock frequency. DPTR pointed to the external memory location. It holds an address of the external memory. Through that accumulator, I can access this DPTR, that is external data. And we have the internal RAM. This is what internal RAM, that is 128 bytes. And internal ROM, we have internal ROM, that is 4K internal ROM. So this is all basically we learned, we need to explain each one by one. So before going to the register content, as we learned about accumulator and the B register, we'll see the memory management of the 8051. So 8051 memory structure, it has a program memory. Totally we have the internal ROM. This is your internal ROM. When EA is equal to 1, it is taken as internal memory location. So this we can use to store our program. So totally we have the program memory, it is 64 kilobytes. I'll come to the later to the code memory. So whenever we have an EA is equal to 0, it consisting of total 64, like 60 is external and 4K is internal. Total it is 64 kilobytes when EA is equal to 0. And we have the totally we have the 64 kilobytes. We have the data memory. Internally we have the 128 bytes of RAM. This is we use to store our data. So this is also enabled when EA is equal to 1. Whenever EA is equal to 1, it is access only the internal memory, that is a 4K of ROM as well as a RAM. So we have the special function register. I'll come later at what are the special function registers to support your 8051. And data memory externally we have that is 64 kilobytes. When EA is equal to 0, it is taken as external memory of data memory, and program memory is 64 kilobytes. So I'm repeating once again, when EA is equal to 1, it takes the internal memory of 4K ROM and 128 bytes of RAM. Whenever EA become 0, it is taken as external memory of program memory is 64 kilobytes and data memory is 64 kilobytes. So we have the internal RAM structure, direct addressing and direct and indirect addressing. We can access the RAM memory. So remember, direct addressing the area whichever it is in the RAM, that is what the special function register we call as a special SFR registers. So direct and indirect addressing area in the RAM, so totally it is 120 bytes of RAM. So totally internal RAM structure, it defined as 128 bytes as well along with your SFR register. So we'll see the special function register, that is what we called as SFR register, and we can see one by one. See, this is the diagram. This part we can say is the number of bits. It is an 8-bit or 16-bit, and this gives the address of that register, and this area it is mentioned as name of the register. So we call the math register. Probably it is used to multiplication and division. So we have A and B register. The name we called as A register and B register. This is accumulator register and this is base register. This is a 8-bit register, both are 8-bit register and both are bit addressable register. Remember, this is, we can address these register by bit. So this is the starting address of A register, that is directly we can access by using E0, and B register I can access directly by F0, that as an address in the RAM area. And similarly we have the flag register, that is also we called as PSW register. It is also 8-bit register and the address is D0. So I want to access the flags directly through the address is D0. Even this PSW is also bit addressable register. And one more, we have the stack pointer. It is also 8-bit register. Remember, stack point is also 8-bit register. It started address as we comes to know that 07. It is a starting address. And the address in the SFR, it is 81H. Next we have the program counter. As we know that it holds an address of the instruction. It is 16-bit address. Because it is holds an address of an instruction, it means that it doesn't have an address. Remember, this is very important. Program counter, that is we referred as PC, it doesn't have any address, but it holds the address of an instruction. It is 16-bit register. Next we have the DPTR. It is 16-bit register. It is splitted into higher order and lower order, that is DPH and DPL. That is also we called as a data pointer. These register we are used to access the external memory. So totally it is 16-bit. Each one we have the 8-bit DPH and DPL. So that is the starting address is 82. It is lower order. 83 is in higher order. So remember, after your stack pointer, the next register is only the data pointer register. Okay. Next we have the timer register. Timer register, to control the timers and configure the timer, we have two register. All are 8-bit register. One we have the timer mode, T mode we call it as, and one more T configuration, Tcon we call it as. Both are 8-bit register. Remember, mode configuration, it is not a bit addressable, but configuring the timers T0 on T1, it is bit addressable. That's what it is, bit addressable register. It is also 8-bit register. So we can generate a clock frequency, we can generate a delay that can be configured through this register, and the mode of operation at mode 0, mode 1, mode 2. So that will be configured by T mode register. So we have the timer register, particularly which timer I can use to configure our mode operations, or timer 0 or timer 1. So remember, these timer register are not the bit addressable registers. Only Tcon is only the bit addressable. See that we have the two timer TL0 and TL1 are the lower order, and TH0 and TH1 are the higher order, as all are 8-bit register, and these are the address it is held by your timer registers. Similarly, we have the instruction point register. it points to the instruction. It is also a bit addressable, and in instruction enabled register, that is IE, that is sometimes we called as interrupt enable IE register, and interrupt pointer register. So this is all our interrupt register, all are 8-bit register. When we have the interrupt pointer register, interrupt enable register. So for serial data communication, we are using and configuring the communication. We can use serial configuration, SCON, and you need to store the data by using the S buffer register. It holds an 8-bit register, and to configure that we can use the PCON register. So serial and parallel configuration. S is for serial, P is for parallel configuration. So serial communication and parallel communication can be done. It is a full duplexed. And also we have the ports. 3 ports we are having: port 0, port 1, port 2 and port 3. All ports are 8-bit register. Starting an address is 80, 90, A0 and B0. Totally we have that 18 to all are 8-bit. So 4 ports we have. So totally we have 32 IO lines. Each are bit addressable. I want to port 0.0. I can read or write. I can set or reset. I can do. This is port 0 bit 0. So likewise in all the ports I can make out to set or reset by the port, because it's a bit addressable register. So totally we have the special function register from starting addresses 80 to F0. So all are special function register. So in the next video we are going to start with program status word of the 8051 microcontroller. Thank you.